Assalamualaikum warahmatullahi wabarakatuh. Today is a week 3 lesson, and this in week 3 lesson I will teach you on the exponential smoothing on the time series. Okay, for the exponential smoothing, what you need to do is you have to download the SPSS software. Okay, software right, from the internet. Uh, and this is the free version. You can get a free version from the internet. And then for the exponential smoothing, we can also calculate by using what you call we use manually to calculate the exponential smoothing. But in later part, for the regression line, by using least squares method and multiple regression, we need to use SPS software, and also we need to use Excel to calculate Excel to calculate the what we call the regression line. Now, for the exponential smoothing, um, this is a concept of weighted moving average. Okay? The weights will decline, and the weights for this will decline, for the regression line will decline exponentially, and the most recent observation uh, we give more weight. Okay? So if I have like this, the exponential smoothing EI, for example, EI is equal to, let's say I have EI multiplied by, and let's say YI minus 1 plus by E, sorry, 1 minus by E, 1 minus by E, 1 minus by E multiplied by YI. This is a general formula. So the weight here, the value for weight here ranges from 0 to 1. Okay? Then we choose if we give a weight close to 0, meaning that we try to remove uh, cyclical and irregular components, and then close to 1 for the forecasting. Okay? So then look at one example here. For example here. Okay. Now let's say I have the value here. So let's say sales for year 94 to 99, and the sales here is 252276. This is sales for 94 to 99. Now I want to use the exponential smoothing to do a forecasting. So uh, for the first value here, your exponential smoothing here. So the exponential smoothing here is equal to or the trend value here is equal to the exponential smoothing or trend value here is equal to the first one, E1 is equal to 2. We take the value of 2 here. We take a value of 2 here, this value, and then for 19, then the F1 we do not have F1 here. F1 is not applicable. So F1 refer to the previous one. We do not have data for a previous one. I just cancel all these numbers. Okay. Now, E1, how to calculate here? E1 here. E1 is referred to Y1. Here, this is Y1, here is Y2, and this is Y3. This is Y3, Y3. This is Y4, okay, and this is Y5, and here is Y6. The cells here, okay. Y1, Y2, Y3, Y6. Now, this E1, the first value here, E1 will take a value of 2 here. Okay, just put 2 here. And F1, we do not have a value of F1 because of the previous one, there's no value in the previous one. We do not have the data on 1993. So we do not have a 1993. So F1 not applicable. Now E2, we apply this formula. E2, setting W1, W is equal to 0.02, then 1 minus by W is 0.8. So we set, you can set any value here. So any value here. So if you set a smaller value here, if you set a small value here, meaning to say you give a more important to the, you give a more important to the previous weight. If you set big value here, greater than this one, if you set more than 0.5 here, meaning to say you give a less important to the previous data. Less important to the previous data. So for this case, I set W 0.2, and of course 1 minus by W is 1 minus by 0.2 is 0.8. So I give less important to the previous value, and I give more important to the previous value and less important to the current value. So W is 0.2 and 1 minus by W is 0.1. So as I said just now, E1 is referred to Y1 and E2 is referred to, we apply this formula. So W is 0.2, okay, multiplied by Wi. Wi, so E2 is equal to W is 0.2, so Y2 is equal to 5 plus by 0.8 multiplied by E2 minus 1. E2 minus 1 is equal to E1. So E1 is equal to 2 here. So the value here is equal to, if you solve this part, you will get 2.6. Now your F2 is referred to the previous E1. F2 is referred to the previous E1. So F2 is equal to, the forecasting value is equal to 2. And then F3 is equal to, we refer to the F3 is equal to E2. So F3 is equal to E2, F3 is equal to 2.6 because of we just calculated just now, E2 is 2.6. So F3 is equal to E2, 2.6. Now E3 is equal to 0.2 multiplied by Y3. So Y3 is equal to 2. So here it is Y3. Y3 is equal to 2 plus by, so 1 minus by W is 0.8 multiplied by E2 minus by 1. Right? E3 minus by 1. So this is a E3. E3 minus by 1 is E2. So E2 is 2.6. So this is 2.6 we get from here. Now, if you solve this one, is 2.48. Meaning to say your F4 is E3. F4 is equal to 2.48. Now E4 is W is 0.2 multiplied by Y4. Y4 is 2.0 plus by 0.8 multiplied by E3. So E3 is 2.48. So you get 2.384. Meaning to say your F5 is equal to E4. F5 is 2.34. Well, E5, this is E5. So here, this is E5. This is E5. This is E5. This is E5. Now E5 is equal to 0.2 multiplied by Y5. Y5 is equal to 7 plus by 0.8 multiplied by E4. E4 is 2.384 is equal to 3.307. Meaning to say your forecasting for F F6 is equal to E5. These are F6, F6 equal to E5 is equal to F6. F6. F6 is equal to 3.07 because our F6 take a value of E5. Then your E6. E6 is 0.2 multiplied by Y6 plus by 0.8 multiplied by 3.37, which is E5 is equal to 3.846. Because we do not forecast on 2000, we just leave them here. Unless you want to forecast for the year of 2000, we need to say your F7 here, F7, forecasting for 2000 is equal to 3.846. This is your F7. Okay. This is your F7. So these are the method how to apply exponential smoothing in calculating the time value and to do a forecasting. Okay, next part. So you can also draw a graph here. So draw a graph for forecasting here. So you have your original data. Your original data is we start with 94. 94 we have 2. 95 we have 5. Then 96 you can plot here is 2. 96 2. 97 2. 98 is 7. And 99 is equal to 6. Then you can also plot your trend line, smoothed trend line. So E1, this refer to E1, E2, E3, E4, E5, and E6. This is how we draw the graph here. Okay. So here is this is Y1. Here this is Y1. This part is Y1. Y this is Y1. Y1. This is Y1. Y this is Y1. So this is Y1. Here is Y1. And the red one is a E1. And this is your Y2. And this E2. This is your Y3. And here is your E3. This is your Y. E4. The red one is a E4. Here is your Y5. The red one is a E5. Here is Y6, and the red one is a E6. So these are how we draw a graph here. Okay? These are sales and yield. Now, the other method of calculating the trend line is by using a linear regression. So, by using a linear regression, you can use a method of least squares. What I have mentioned last week is the method of least square is we can use we have a sales here. Okay? So the sales, the previous number seed is 94, 95, 96, 97, 98, and for the 99, here 99. The series here is 2, 5, 2, 2, 7, and 6. So to find the regression line, to find the trend line, we use a least squares method by applying the regression line uh, by using a least squares method by applying the regression line. And the calculation of for B1 is equal to n summation xy minus by summation of x summation of y multiplied by n summation of squared minus by summation of x squared, and B0 is equal to summation of y and y divided by n minus by B1, we take a value from there, summation multiplied by summation of x over n. So if we solve here, we try to, if you solve here, you can get, if you sum here, you can get the value here. So let's say we try to solve manually here. You can easily use this thing by using what you call the um, Excel, or you can use the SPS. I would like to use, I prefer to use SPS, but because of this SPS is quite powerful software to find the location. So let's say we calculate it manually here. So now to find the B1, so we need to find the summation of x, y. So let's say I have I just cut this data. So let's say I have this here. So let's say we go to there. Now my data here is 94 up to 96. I have 94 up to 96. So the value is a year from 94, 95, 96, 97, and 98. Then you have the 252276. 252276. So we have 252276. We have here, sales here. Sales here is sales here. Sales is equal to There is 2, 5, 2, 2, 7, 6. So here is 99. So since here is y, y, then you need to give the because of regression line involve x and y, so the independent variable and these are dependent variable. So your independent variable is x. X value you take from here. So because of this qualitative data, so we have to convert the decode data. So here you can start with 0 here, or you can start with 1, 1, 3, 5, 7, and 9, or I can start with 0 here, 0, 1, 2, 3, 4, and 5. We start with 0. Or if you want to start with 1, so we have 1, 3, 5, 7, 9, and 11. Okay. So because of the formula there, your trend line for y, the trend line is equal to b naught b sub o plus by b1 x. Okay, this is your trend line. Okay. Or in other words, t sub I is equal to bo plus by b1 x sub I. Okay. So b1 is equal to n summation of xy minus by summation of x summation of y divided by n summation of x squared minus by b squared minus by so your b1 is n summation xy minus y summation xy divided by n summation of x squared minus by summation of x everything square here. This is your b1. Okay. So now, first of all, we try to find b1 here. So in order to find b1, we need to find xy because of here involve x multiplied by y. So we need to find xy here. Xy means x multiplied by y. So here is x, this is your y. X multiplied by y here is 0. 1 multiplied by 5 is equal to 5. And here is 4. This part is equal to 6. It is 20, 14 is 38. Then here is 30. So xy, summation of xy, meaning to say you have to find the total here, summation of xy. So if I sum here, I get 10, 40, 68 plus by 5 is 73. Okay. So 10, 40, 68 plus by 5 is 73. This is my summation of xy. Then this formula also involves x squared, summation of x squared. So we need to find x squared here. X squared. So x squared. So the first one is 0 squared is 0. So 1 squared is 1. 2 squared is 4. 3 squared is 9. Here is 16. And this one is 25. Okay. So if I add this together, okay, I add x squared together, we get 20 plus by 10 is 30 is equal to 55. So here is 55. Okay. Now this formula also involves summation of x and summation of y. Summation of x, summation of x, summation of x. Yeah. So we need to find summation of x. Summation of x means the total of x here. So here is equal to, if I sum here, add this all together, we get 1 plus by 2 is equal to 3, 6, 10, and 15 here. So 15 here. And summation of y, the total of y here. So the total of y here is equal to, get here. So if I add here, I have 2 plus by 4 plus by 2 is equal to 9, 11, 11 plus by 7, 18, 18 plus by 4 is 24. 24 here. So let's say we do a double check here. We have here 1 plus by 2 plus by 3 is equal to 6, 6 plus by 4 is equal to 10, 10 plus by 5 is equal to 15. Then here is 5 plus by 4 plus by 6 is 15. 15 plus by 30 is 45. 45 plus by 28 is 73. And here is 14. 149 is 14. 14 plus by 16 is equal to 30. 30 plus by 25 is equal to 55. And n here, the n is number of observation here. So your n is equal to 1, 2, 3, 4, 5, and 6. So your n is equal to 6. So n is equal to 6. So by applying this formula, so your B1 here, B1 is equal to n6 multiplied by summation of xy. So summation of xy is we refer to xy here, summation of xy multiplied by 73 minus by summation of x. Summation of x is equal to 15. 15 multiplied by summation of y is equal to 34 multiplied by 34 divide by n is equal to 6 multiplied by summation of x squared is 55 and minus by summation of x 15 squared. Now if you solve this one, the value here you will get the value of okay, you can solve this one. You can solve this one. If you solve this one, you can get the value of b here is equal to say b1 is a 0.743. 0.743. So if you solve there, you can get 0. So b1, okay, b1 b sub 1 0.743. B sub 1 is equal to b sub 1 is equal to 0.743. Is the value for b sub 1. Now, then we need to find b naught. B naught is equal to summation of y divided by n minus by b1 summation of x divided by n. Now, you can solve here. Now, if you solve here, your this b naught is equal to summation of y. Summation of y is equal to 24 divided by n is 6 minus by, so b1 is 0.743 multiplied by summation of x. Summation of x is equal to 15 multiplied by 15 divided by 6. So the answer here is, if you look at the answer there, get the value of answer is 2.143. Okay, 2.143. So here is 2.143, 2.143. So we can write a trend line here. So the trend line here is equal to this trend line. The equation for the trend line is equal to 2.143 plus by 0.743x. This is our trend line. So I just write here. So your t here, t is equal to 2.143 plus by 0.743. Multiplied by x. So this is your trend line. So in order to find a trend line here, you can plug in here. So your t here, the trend line here, you can just plug in here, trend line. So you just substitute the value there. The first one, you can find T1 is 2.143 multiplied by 0.743 multiplied by, because your first 0 is 94, your x is equal to 0, so the value here is 2.143. So the second one, you just apply this formula, 2.143 plus by 0.743 multiplied by 1. So mean to say you have 6, 8 here, then you have 8, 2.886. So that is a trend line for 95. Now the trend line for 96, you just plug in 2.143 plus by 0.743 multiplied by 3. You can get here the value here, and so on and so forth. We just apply it. These are how we calculate the trend line by using the regression line. But the easiest way to calculate this trend line, you can use SPSS software. Okay, so I want to show you how to use the SPS software. So just remember, our value is 252276. So I open my my software here. So I just plug in the value here. This is my SPSS, 252276. Okay, this is my y, so I can change variable name here. So this y, and the other one is x. Okay, so my x there, x is, we start with 0 here, 0, 1, 2, 3, 4, and 5. Okay, then so x and y, then you can try to check again. 252276. Okay, our x is 0, 1, 2, 3, 4, and 5. So now we go to this one. Okay, look at this one. Now my value here is so to find the regression line here. Okay, to find the regression line here, I just clear off this one. Okay, to find the regression line here, so I can go to analyze. Okay, you go to analyze. You go first. You go to analyze. Okay, you go to analyze. You go to analyze here. You go to analyze. Okay, you click analyze. You click analyze. Click analyze. Then you go to regression. Okay. First we need to have a data x and y. Then we go to analyze. Then there will appear a lot of analysis here. Okay. You can select regression. Okay. I repeat again. So first you have to have the data. So these are data x 0, 1, 2, 3, 4, 5. X is referred to year, we give a code, and y is referred to the sales. So to find the regression here, we go to analyze. Then after that we go to regression. Okay. Now, once you click the regression here, there is a subroutine here. There is one more tab here. You select linear. Okay. Select linear. Then they ask you to insert a variable there. Okay. I repeat again. Now, to find the regression line by using SPS, you go to analyze. Go to analyze. Then you go to regression. Then from there is a few analysis here. You select linear here. Then from there, they ask you to insert a dependent and independent variable. We know that our independent variable is x, so we just plug in x, and our dependent variable here is y. We just plug in y. Dependent variable is sales, and the independent variable is your year, your code here, x. So you put x here. Then we just press OK here. And press OK. Then this SPS will give you a value of B0 and B1. This is a value for B0. This is a B0. This is a B0. And here is your B1. Okay. So if you want to go to the previous, you want to go to the data bank, you just click here, or you just click here, or you just click here. Okay, then let's say I want to go to the data, just click here. So go back to the data. So if you want to preview your result just now, you can go to this one. You can go to you can go to this one. You can go to the bottom here. You can click here. This is the result. Okay? If you want to go to the previous data, you just click this icon, minimize. Okay, good. Now, if you want to look at your result, you can click here. You just click here. Okay. So our B here, your B naught is 2.143, and then your B1 is 0.743. This is how we use the regression line. So we can write here our so our B naught, okay, B naught is equal to 2.143, and our B1 is equal to 0.743, and the trend line or the regression line trend is equal to 2.143 plus by 0.743x. These are our trend line. Okay, this trend line by using SPSS. Okay. Okay, this is how we solve the what you call the regression line, the linear trend line by using the what you call the SPSS. Okay, next we try to go to this trend line. So then you can draw the curve there. Okay, next is on the quadratic line, quadratic model. So you can also use a quadratic model depending on the, let's say I want to find, just now I use a linear line. So I want to use the quadratic equation. So quadratic equation involving x and x squared. So if you use the formula, it's quite tedious to solve this one because of involve a lot of calculation. But the simplest way to solve this one, you can use SPSS to solve this part. So now, our data just now is 252276. Okay, 252276, and then the equation here involves x and x squared. So this is our x, and the other part we need to find x squared. So we just square the x value here, and then we get the x. So let's say let's look at this example. Okay, so now we try to, now we know that this is the answer for the equation. Okay, the answer here is 2.857. So we try to use SPS to solve this one to get a trend line here. Let's say I have here my I go to SPSS. Okay, go to SPSS. Okay, so my x here, so I just put here my x here. So my x is equal to, x is 0, 1, 2, 3, 4, 5. Then y 2, 5, 2, 2, 7, 6. Right now, these are my x and y. Now, because of for the quadratic equation, we need to have x squared. So we need to have x squared. So x squared there is equal to 0, 1 squared is equal to 1, 2 squared is equal to 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. Okay, you just key in data here. So we just key in the data here in our table here, in our data sheet here. We just key in data there. Then we can run the quadratic equation. So let's say we key in the data there. So just do this. Okay, so my y here is 2, 5, 2, 2, 7, 6. This is my y. Okay, 7, 6. Okay. Then I have x here. X is 0, 1, 2, 3, 4, and 5. While my x square is 0, 1, 4, 9, 16, and 25. This is my x square. Okay. So I just give a variable here, x. Here is x. This is x square, and here is my y. Okay, that's a view. Okay, I have x, x squared, and y. Now I want to find the regression for this one. Okay, so to find the regression, you go to the same formula. You go to this is a quadratic equation. Okay? So you go to the same formula. You go to analyze. You go to the same method. You go to analyze. Then select regression. Then go to linear here. Even though we want to find quadratic equation, we go to linear here. Now my dependent variable is still y. So I select y here, I put this part. Okay, y here. While my independent variable, I have two independent variables, x and x squared. So x, the other one is x squared. Is my variable. Then I click OK. So this is my regression. The value for b here. So you can write here as a, I repeat again. Okay, I repeat again. Okay. Now, to find the regression, the quadratic regression, you need to key in x and y, And in addition, you need to get x squared. So x squared is just a square of this one, 0, 1, 4, 9, 16, and 25. Even you can use SPS to calculate this one. If you have a big value, because it is a small value, you can use SPS to calculate this value. But it's okay, we just, because it is a small value, we just put 0, 1, 4, 9, 16, and 25. So then you have a y data. We go to analyze. Okay. I go to analyze. Go to analyze. We go to regression. We go to linear regression. So we select. I just put reset here. I select x, y as my dependent variable. Okay, y is dependent. X is independent. X one x. Then the other x is x2. So you have two independent variables. Then you just click OK, and this is the result of quadratic equation. So in other words, our BO, okay, BO, so our BO is equal to, so your BO, so now your BO is equal to, for this quadratic equation, your BO is equal to 2.857, 2.857, this is your BO, okay, this is your BO. This is your BO, okay, this is your BO, this is BO, BO. B1 is 2, B1 is equal to B sub 1, 0 point negative, negative 0 0.329, 329, and then B2, B sub 2 is equal to 0 0.214. So the new equation here, so I can write here as the new equation here become uh, so the trend line here, so the trend line by using quadratic equation, the trend line is equal to 2.857 minus by, because of negative, minus by 0 0.3257 to 29, okay, 29, x plus by 0 0.214 x squared. This is our trend line. Okay. So if you want to find the trend line here, if you want to find the trend line, let's say I have y here. So I have y. So I have x. X we have 0, 1, 2, 3, 4, and 5. So my y there is equal to 2, 5, 2, 2, 7, 6. Then the trend line there, we just apply this formula. So the first one is 2.857 minus by 0 0.329 multiplied by 0 plus by 0 0.215 multiplied by 0 because of x squared is equal to 0. Okay. So your x squared is equal to, the first one, x squared is equal to 0. Now the second trend line is equal to, you repeat the same thing, 2.857 minus by 0 0.329, x is equal to 1, plus by 0 0.214, x squared is also equal to 1. So x squared here is equal to 1. Okay. Now the third trend line is equal to 2.857 minus by 0.329, my x is equal to 2 plus by 0.214. Then the x square here is equal to 4. This is the trend line for the third one, and so on and so forth. You can just solve the problem there. You can get the trend line. This is a trend line by using how we calculate a trend line by using what we call the quadratic equation method. Yeah? So this is a trend line by using quadratic method. So next I go to okay. So the same result here. Okay. So this is the answer here. The quadratic equation. Okay. Y hat here is referred to your trend line. These are referred to this thing is referred to the trend line. This is a trend, the trend line. Trend line. Okay. And learn these methods and okay, how to use when to use the linear trimodal or quadratic trimodal. So these are rule of thumbs when to use the linear trimodal or quadratic trimodal. So you use the linear trimodal if the difference are more or less constant. Okay, the difference use the linear trimodal if the first difference are more or less constant. Meaning to say, y2 minus by y1, y is referred to the sales there. So y2 refer to sales for 1990. Y2 is you get here. Y2 is for sales for 1994. Okay? Now, if you check here, if we check the timeline. Okay, y2 minus by 1, y2 is minus by y1 equal to is approximately equal, cannot be equal, is approximately equal to y3 minus by y2 and so on and so forth. So we are comparing y2 minus by y1 with y3 minus by y2 with y4 minus by y3 and so on and so forth. If the value here is more or less constant, constant means they give a similar value, the value is almost the same, then you use the linear time model. We use the regression quadratic time model if y3 minus by y2 minus by y2 minus by y1 equal to y4 minus by y3 minus by y3 minus by 2 and so on and so forth. If this thing is more or less constant, so we use a quadratic trend. Okay. So here is like this. Um, so I put this now. So we have y1, y2 up to y6, isn't it? So now let's say I find if now if if y2 minus by y1 approximately equal to y3 minus by y2 and approximately equal to y4 minus by y3 approximately equal to y5 minus by y4. So we have up to approximately equal to y6. So we have y6 minus by y4 or y5. Okay. If approximately equal, then more or less constant, then we use linear trend. Now, if we have here, let's say I have here y3 minus by y2, then minus by y2 minus by y1 approximately equal to y4 minus by y3 minus by y3 minus by y2 and approximately equal to y5 minus by y4 minus by y4 minus by y3 and approximately equal to, we have up to y6, isn't it? y6 minus by y5 minus by y5 minus by y4. Then we use, if this is the case, if this is a more or less constant, we use the quadratic trend. We use the quadratic trend. Here we use a linear trend. So these are how to decide how to select which method to be used if you are given a set of data. Okay. Now next part is then when to use the exponential smoothing, exponential trend. So for the exponential trend, if you calculate y2 minus by y1 divided by y1 multiplied by 100 approximately equal to y3 minus by y2 divided by y2 multiplied by 100 and so on and so forth, then you use, okay, for this case we use, let's say I have here, okay, now I have up to y6. Okay, so if I have y1, y2, y2 minus by y1 divided by y1 multiplied by 100, just put like this, approximately equal to y3 minus by y2 over y2 and approximately equal to y4 minus by y3 divided by y3 approximately equal to y5 minus by y4 divided by y4 and this also approximately equal to y6 minus by y5 over y5. Then we use what we call the exponential trend. Exponential trend, because of the exponential trend, the formula is E equal to W multiplied by 1 minus by W multiplied by Y, isn't it? Okay. We use the, what you call the, sorry, multiply by E minus by 1. So here is multiplied by EI minus by 1. You can check the formula here. It's not wrong here. There is EI. Okay. So we can use the, what you call the exponential trend model. So these are how to decide which trend model to be used if we are given a set of data. Okay, I think that's all for today's lecture. So I will give you a more lecture, will prepare more video. this. Then for the next lecture, I'll give you how to use or how to find the triangle line by using House-Winter method, and then we have to we have to we have to find we also want to use the auto regression modeling. Okay, so for the next lesson, I will show you how to use the House-Winter method to do a forecasting, and then the auto regressive model to do the forecasting. I think that's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.